So this is a parallel circuit is given. There will be the resistor. 3 resistors are connected in parallel. They are connected to the supply. Resistance R1 is 120 ohm. Resistance R2 is 150 ohm. Resistance R3 is 220 ohm. They are connected in parallel, then connected to supply. Firstly, we have to find out the equivalent resistance. We need to find out the equivalent resistance. So that both three resistors are connected in parallel. Therefore, we can write down the equation. If the resistors are connected in parallel, R total equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is for the parallel resistance. And if you connect the resistor in parallel, R1, R2, R3 are connected in parallel, then connected to the voltage source across a V. In this case, all the resistors, they got the same voltage. Supply voltage V, resistor R1, R2, R3 are connected in parallel. Therefore, the voltage across R1 is V, voltage across R2 is V, voltage across R3 is also V, the same voltage. And the resistors are also drawing the electrical current. The current in the R1 is a I1, the current in R2 is a I2, the current in R3 is a I3. I1, I2, I3, those are the current flowing into the resistors R1, R2, and R3. So that if you connect these resistors in parallel, total supply current is a IT. IT equal to I1 plus I2 plus I3. This is a rule. Firstly, if you connect the three resistors in parallel, 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the first concept. Second one is, if you connect the three resistors in parallel across the voltage, supply voltage V, so all the resistors, they got the same voltage. Voltage across R1 is V, voltage across R2 is V, voltage across R3 also the V. And resistors are drawing the electrical current. So the current I1, I2, I3, their sign equal to supply current IT. And also we can also calculate current into the resistor R1 is V by R1. Current in resistor R2 is V by R2. Current in resistor R3, I3 is equal to V by R3. Those are the current flowing into the individual resistor, which are connected in parallel. So the current in resistor R1 is I1 equal to V by R1. The current in the resistor R2 is I2 equal to V by R2. The current in resistor R3 is I3 equal to V by R3. So those are the formulas. So that we can write down the equation as well. 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by R3. So that we can reverse it. By reverse it, RT equal to numerator is 1, denominator is 1 by R1 plus 1 by R2 plus 1 by R3. Those are the concepts of the parallel connected DC circuit. All the resistors are connected in parallel. We write down the equation 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by R3. And also RT equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. And voltage supply voltage also equal to the voltage draw across each resistor because they are connected in parallel. So the R1 voltage is V, R2 voltage is V, R3 voltage is V. We can calculate the current flow into the R1, V divided by R1. So I1 equal to V by R1. The current flow into R2, I2 equal to V by R2. The current flow into the R3, I3 equal to V by R3. We also calculate. And all the branch current, I1, I2, I3. So we add the all the individual branch current, then we can calculate the supplying current ID. Therefore, ID equal to I1 plus I2 plus I3. So those are the concepts of the parallel circuit. Then based on this principle, we calculate this problem. So in this case, R1 120 ohm, R2 150 ohm, R3 220 ohms are connected in parallel. Therefore, we need to calculate the total resistance. So we write down the equation. R total equal to 1 divided by 1 by R1 plus 1 divided by 1 by R2 plus 1 by R3. So that we can now substitute. R1 is 120. So 1 by 120. R2 is 150. R3 is 220. So we saw this one, numerator is 1. So 1 divided by 120. So you got the 0.0833. 8.33 into 10 power minus 3. 1 divided by 150. So this is a 6.67 into 10 power minus 3. Now 1 divided by 220. So this is a 4.545 into 10 power minus 3. So that will be the weekends are add together. So that will be we add 8.33 plus 6.67 plus 4.545. So you got 19.545 into 10 power minus 3. So this 10 power minus 3 go to numerator. 10 power 3 divided by 19.545. So the 1000 divided by 19.545. 1000 divided by 19.545. So you got the 51.160. So this is a equivalent circuit of the three parallel connection. Then we also need to calculate current flow into R1, R2, and R3. Supply voltage is 12 volt. So if the supply voltage is at 12 volt, we need to calculate current flow into R1, R2, and R3. So in this case, V equal to 12 volt. We need to find out the I1, we need to find out the I2, we need to find out the I3. So in this case, you can see supply voltage 12 volt. So all resistors R1, R2, R3s are connected in parallel across a 12 volt. Therefore, the voltage drop across a R1 is a 12 volt. Voltage drop across a R2 is 12 volt. Voltage drop across a R3 is also 12 volt. Therefore, that we can write down the equation. The current need to be calculated. The current in the R1 is I1. I1 equal to V by R1. So V is 12 volt. R1 is 120 ohm. 12 divided by 120, you got the 0.1 ampere. And similarly, we can also calculate the current flowing into the resistor R2. So the current flowing into the resistor R2 is I2. I2 equal to V by R2. So voltage is a 12 volt, resistor is 150. 12 divided by 150, you got the 0.08 ampere. We also need to calculate the current flowing into a resistor R3. The current flowing into resistor R3 I3. The voltage is also 12 volt. So the 12 divided by R3 value 220. So you got the current is 0.055 ampere. So this is the way that we can calculate the all the current flowing the R3. And then we also need to find out the So this is for this problem solution. So we also can calculate total current ID. So in this case, the total current ID can be calculated. Because of the parallel connection, ID is equal to the I1 plus I2 plus I3. Therefore, the ID equal to I1 plus I2 plus I3. So we substitute the current value. I1 is 0.1, I2 is 0.08, I3 is 0.055. 0.1, 0.8 and 0.55 you add together so that we can calculate 0.1 plus 0.08 plus 0.055. Then you can calculate it as 0.235 ampere. 0.235 ampere. This is the way we can calculate the total current. Therefore, I summarize this concept. If you connect the three resistors in parallel, we can write down the equation 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by R3. So the RT equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. This is the first concept. This is the first concept. And if you connect the all resistors in parallel, the voltage are the same. So supply voltage V, resistor R1, R2, R3 are connected across the supply. Therefore, that we can write down the equation. Voltage drop across the R1 is V, voltage drop across the R2 is V, voltage drop across the R3 is V. So that we can also calculate the current flowing the individual resistor. So current flowing into the R1 is I1, the current flowing into the R2 is I2, the current flowing into R3 is I3. In this case, I1 equal to V by R1, I2 equal to V by R2, and I3 equal to V by R3. This is the concept. Then we can also calculate the total current. Total current is equal to sum of the all branch currents. So therefore, the IT is a total current equal to I1 plus I2 plus I3. So those are the concept of the parallel circuit. So this problem is resolved by using by following those same concepts.